And then let me start sharing, and we'll carry on with okay, well, that's a good question. So the first, let me just start sharing my screen, and then we can deal with that question and carry on and maybe do an example. So the question was about, under what logic will we declare a class as private? So if it's a helper class, right? So basically some classes exist only to serve other classes, and you never ever use them outside of the class itself. They just purely exist to support it. In those cases, you could make the classes private, either by you can do a thing called an inner class, where you declare a class inside a class, or you can just declare them separately but not expose them in the header file. So we will look at those options when we do linked lists, because linked lists have a class that goes along with them called an iterator, whose job it is to give you access to every element in the list. But you often don't care about that from outside the class so much. Sometimes you do. So it might make sense to use a helper class to implement those. So we'll take a look at various options. It's a good question. What happens if we use a helper function in public? Is it bad practice? No, not necessarily. This is where computer science actually becomes, in a sense, this is more software engineering. Whereas engineering, you often have to make these decisions about what seems to be the best in a given circumstance. Science is, obviously about finding out the truth, and engineering is about practically building something. So is it bad practice? Like, not necessarily, but if you pollute your names, or if you pollute your header file with too many things that are public that people aren't interested in, then that is bad. So it's very context specific. So I try and limit the amount of things that are publicly visible to only things that I think the users of my type will be interested in. Then I, of course, run the risk of misjudging and not exposing something that does turn out to be important. So it's a bit of a balancing act. Unfortunately, only really experience can give you a sense of what the right level of publicly exposed things is. But I mean, if you've decided internally that it's a helper function already, then you've already made the decision that it's just to be used to help this class out. So then I think if you think it's a helper function, then you don't need to expose it. But the question becomes deciding, is this just purely a helper function, or does it have more general use? And there's no easy answer to that. All right, so let's carry on with slides. I thought I had them. Okay, well, let's find them. And clearly this is not going to remember exactly where we finished off from. So let's just we'll zoom through, and then when I think we've hit enough for doing an example, we'll switch over to doing an example. So we're looking at two different techniques, overloading and generics, and they're each fairly substantial and require a whole content-filled practical example each. So the set of slides will last us 2 weeks. So here we're doing operator overloading, and we looked at what an operator was. It's these punctuation-like parts of an expression that have sort of understood meanings, like incrementing and comparison testing, and you can use them sometimes meaningfully as an alternative for member function names. Obviously, if you use them weirdly, it's going to be less useful than not using them at all. We discussed what syntactic sugar was, in the sense that there's nothing you can do with these that you can't do without normal member functions, but it does sometimes make your code easier to understand, and in that sense can be a benefit. So we use it. So overloading an operator extends the definition to work with your particular type, and you can use it in combination with existing types and your types, but you can't replace the meaning for pre-existing types completely. So you can't change the meaning of the operators for integers or for doubles or for any other pre-existing class type, but you can define what it means to use those other pre-existing types in relation to your operator, to your class, without any issue. We saw that there's a new keyword, the operator keyword. I like to write in a style that sort of pretends that the member function name just includes the name operator, because at the end of the day, the overloaded operators turn into function calls, either member functions or non-member functions. And then, so that's the basic syntax. As we saw, the return type, keyword, operator, and symbol. I tend to write them right next to each other. Parameter list, so it's just a function. And then if it's doing it as a member function, you'll include it in the class definition. But not all possible patterns can be implemented with member functions. Some, particularly cases where your class is not the left-hand side in a binary expression, you have to implement those with non-member functions. And typically, you'll want to upgrade the access of those non-member functions to give them the ability to manipulate the private state of your classes, and to do that, you declare them as friend functions. We saw that there's some rules, some restrictions. You can't change the precedence, so that's the order of operations. So like BODMAS, PEDMAS, PEMDAS, however you learned it, you can't change those rules. And associativity, so when things have the same precedence, then they're evaluated either in left to right or right to left order. So it's a disambiguation for things of equal precedence. Things like multiplication and division, addition and subtraction all have the same level of precedence. So if you've got an expression that mixes them, what order do they get evaluated in? You can't change the you can't use default parameters. You can't change that number of parameters, because the number of parameters is the arity of the operator. And arity, like there can be a couple of arities, but you can't add completely new ones. So for example, minus could be just negation. So you want to set your thing to negative, whatever that means. Maybe if you're doing like a vector type or a data set type, you want to then just negate every element in the data set. That will work as a unary operator, because you only specify your thing as one parameter. But sometimes you want to use minus in a binary expression, the left-hand side and the right-hand side. When we say binary there, we're not talking about ones and zeros. We're talking about the number of operands to each operator. So if you want to use minus in an infix way in between two operands, that's a binary version of it exists, but you can't suddenly make it ternary or quaternary or anything else like that. So you can only work with the number of parameters that are already predefined for it. You can sometimes change there's some exceptions. Let me just see. There is the function invocation operator, which basically lets you treat your class as if it were a function. And obviously the number of parameters into a function is arbitrary. So I think we'll do that one just as a counterpoint. So it's allowed to have an unlimited number of parameters, but the other ones aren't. So you can't change that on a per operator basis. You can't make new operators, so you can't just say, I want to have this sequence of punctuation mean something. Very few programming languages let you do that, but some do. One example of one that will let you do that is Scala, for example. And you can't change very limited list of pre-existing operators. So member access is too fundamental to how everything works to allow you to change. This weird indirect member access, you almost never use it, but it's a very a peculiar combination of reaching into a particular class at a particular point. It's not the same as dereference followed by dot, which is the arrow operator. This is almost never used. Scope resolution, also too fundamental. You've used it for namespaces. You've used it for fully qualifying a member function name. Ternary operator we looked at. We saw that that's the equivalent of an if then else statement. It's the only ternary operator that exists, also known as the conditional operator. You can't overload it, so you don't have to worry about how would I specify a ternary operator. And size of is actually an operator, not a function, although I tend to use it as if it were a function, but you can't overload it anyway, so it doesn't matter. And you can't change how it works with pre-built types. And the idea is to basically define how these operators relate to your data structure and other instances of that data structure or other data structures that already exist. That's the goal of operator overloading. We've seen that every member function in a class automatically gets an extra parameter called this, and it's hidden, and it refers to the current instance of the object. And we manually did that when we did pseudo classes and pseudo objects. We called it maybe object self or object this or whatever, but pre-built in. We haven't really needed to use it until now, but it does have some use for disambiguating member function names to parameter names if they happen to be the same. But we will make more use of it while we do operator overloading now. And then we've seen that you can, as I said, some operators need to be implemented as non-member functions, but we still want to grant them privileged access to the private state of the class. So inside the header file, it looks a lot like a member function, but it isn't. We define it to be a friend function with the friend keyword. Hey, two new keywords in one lecture. That's unusual. And then the important thing to remember is that it's still not a member function. It can't access this because it's not part of the class, and you must fully specify all of the parameters. With every member function, the implicit first parameter is yourself. So if you're specifying, let's say, addition using a member function, you'll only specify the right-hand side. You are taken to automatically be the left-hand side. Whereas if you do it with a non-member function, you must specify both the left-hand side and right-hand side. So our goal in life will be to try and use member functions wherever possible because it's more encapsulated. That's our style. There are other styles that go completely the opposite way and just try and use non-member functions with preference. We won't. There are other ones which you have to implement as member functions, so there's no way to just fully go one way or another. So our goal will be to default to member functions and use friend functions if we have to. Remember, granting friend privileges to other things comes at a cost, at a risk of something going wrong. This thing technically isn't part of the class, so you are weakening encapsulation a bit if you do that. And then we specify the full parameter list, and we don't specify a fully qualified name, so there's no class name in front of it. It's just a regular external function that's been upgraded. And then, as I said, conversely, there are some member functions, or some operators that have to be member functions. For example, the function invocation operator, indexing operator, the arrow operator, and very importantly, the assignment operator must be implemented as member functions. So these are all nice to have. You don't really care. The assignment operator, however, is something we will pretty much always overload in our classes if we have dynamic memory internally. So, sorry, just hang on. I have to respond to something. I just want to pause for a moment. I apologize for the delay. All right, thank you for that. There's been some scheduling problems because some people have forgotten that today is a Monday, but let me continue. Oh yeah, don't forget the late attendance code. Let's actually take this opportunity to look at the comments. You know what? That is a good code. Let's do that. Your code wins. Your code is the code we will use for today. So there, that is the official code for today if you're watching this from YouTube later. Cool. All right. So, whoops. Well, it didn't matter. That was just the UJ, the assistant lab, open lab. So nothing that you couldn't see normally. All right. So when it comes to inheritance, we just include all possibilities which the child classes could have and use those that are required for each child class. For example, with UJ shape, could we include all? Yeah. Look. So in practice, you should try and imagine every possible way that someone will want to use your class in that class and its derived classes and provide constructors for all of them. Now, that's a lot. So we don't expect you to do that in a test. In a test, we expect a no-args constructor, a fully parameterized constructor, and a copy constructor. And unless we specifically tell you about some other constructors, those three will be enough. So good question. Interesting. Okay, I'll look into that. I thought I had, but maybe I didn't, or I uploaded them to the wrong subject, which I'll have to follow up on. So thank you for bringing that to my attention. All right. So let's carry on. So these have to be member functions. If the operator is overloaded for it, yeah, I think this is what I said earlier. So the basic idea is that the implication is, if you're a member function, is that you're the left-hand side of the of the class, and this is the reason why these need to be when these things, how you decide whether this should be a member function or a non-member function. Default to member function, but if you are the left-hand side, it has to be a friend function or a non-member function at least. However, if you are the right, if you are the left-hand side, then you should do it as a member function as possible, or if possible. All right. Yeah, so I think that's basically just what we said. You've got a choice for a binary operator as either member function or a friend function. We will default to member function if possible. So here's just the abstract way of writing it. So if you operator whatever, in this case, this one would, if we're doing it as a non-member function, so you must then include the class on the left-hand side, whether or not you do it as a, sorry, did you say function prototype? This is as a member function, so you're just specifying the right-hand side. It's not necessarily going to be a class, actually. It could be, for example, if I want to add an integer to me and I'm a collection of integers. So it doesn't necessarily have to be a class, and it doesn't necessarily have to be const or reference either. That's just very common that you'll define a bunch of these operators to say how you combine instances of your class. But you can, of course, specify other pre-existing classes as well, and we will. And then in implementation, you just implement it as a member function, fully qualify the name, and then do whatever it is you need to do on the inside, and then return whatever value it is you said. They can be void as well, but mostly they're value returning. So we'll see, gosh, are there any examples? I could make one for void, but they're almost always value returning. And then if you're doing it as a non-member function, you have to specify both the left-hand side and the right-hand side. Again, not necessarily classes. They could be other types as well, but it's most common to define how you're combining instances of your class, and then do whatever it is you need to do and return again at the end as well. Difference being, of course, here, we can't use this. Here, we can use this. This doesn't make sense in a non-member function because we are not a... we're not part of the class. Ones that we will make extensive use of are ones that we'll make extensive use of are stream insertion and extraction operators, which will allow us to send the messages, which will allow us to basically treat our object as if it were a stream, which is a very useful metaphor to have. For example, if we implement the stream insertion and extraction operators, we can then stream directly into our class using cin or cout, or later on using file streams for input and output. They are it's a very powerful and useful technique because you can sometimes structure your code in a completely stream-oriented way, having data flow from one class to another class to another class through a series of stream operators. So we'll definitely, your chances are very high in the second semester test of getting one of the two stream operators, either insertion or extraction, because it is very useful and a good example. One thing that's interesting about it is, of course, that it's one of these cases where we have to use a non-member function. If we look at it like this, say we've got our object and it's O. Who's the left-hand side here? The left-hand side is cout. The right-hand side is us. If we're not the left-hand side, then C++ will try and do something like this operator, blah, and specify O as the object. Sorry, not 0, O as the parameter. Now cout won't have a pre-built-in member function called operator that understands our object type, because our object type comes after cout. It doesn't exist yet. But what would make sense is to convert that into something like this: operator, whoops, too many arrows there, operator blah, and then specify cout and our objects as the right-hand side. So these stream operators will always need to be implemented as friend functions. The basic question then is, what is the return type of an output stream as well? We can do stuff like this. Cout, it's just cout1 and a space and a 2 and an end of line. You can chain these operators together, have long sequences of them. How does that actually get evaluated? Well, it gets evaluated from, and this is why it's important that we can't change the arity of these things. This gets evaluated from left to right, so that gets evaluated first. So that will become cout. Oh, the cout. This one will have it. So cout.operator 1, or if we're going to pretend, let's go like this: cout blah. Right, and then the rest of this still gets evaluated. And then something needs to be returned here. So what needs to be returned is something that's still compatible with the stream operator and the rest of the sequence. So what gets returned is the stream itself. So this basically, the output happens, and then cout gets returned. Then the next one gets evaluated, and cout gets returned. And the next one gets evaluated, and cout gets returned. And then obviously it's done. Cout gets returned. Nothing happens with cout. It just gets it's done now, but it still gets returned at the end. So that's how these long chained expressions get evaluated. So for that to work, our return type needs to be a compatible stream type. So there's basically, as we discussed when we looked at inheritance, a hierarchy of stream types. There's the iOS streams at the top, then they're split into I streams and O streams for inputs and outputs. So an an O stream handles output operations. And if you think of it like this, how do I remember which one to use? Well, just write it out. If this were cout, and I was doing it like this, oh, cout goes with that stream. Whereas if we're doing it the other way, oh, an I stream goes with that kind of symbol. So you can always remember what the return type needs to be. And then the first parameter, as we saw, it gets turned into calls like this. So it's so it gets evaluated like that. So you can see that the first input there needs to be the same stream type. So for input for cin, it would be operator what, and then cout, and then that. So we can see, okay, this particular thing, its return type must be cout, and its first parameter must be cout, or an O stream. And also, for what it's worth, it's always an O stream reference and not a const reference. Why? Because we want to change the contents of the stream by sending values to it or reading values from it. But there's only one copy of these streams in existence because they're tied to a particular terminal. So you can't duplicate it, send data to it, and hope that it still works. They actually stay fixed. So that's why it gets passed through as a non-const reference. We don't want a copy of it. We want to be able to change it. So it's non-const, but it is a reference. And then that's the reason why the signature looks like this. And again, remember, it's a friend function, so it doesn't get fully qualified over there as with the function name. Then you do all the stuff, and you return the stream itself at the very end so that chaining can continue. Exactly the same story with the extraction operator, except now it's an I stream, and we can figure that out easily just by remembering what a stream operation looks like. Input with that symbol, and then obviously the first parameter and return type must be an iStream reference, and then carry on. One thing to also note with this one here, the whole point of streaming into a class, let's say we're streaming into O, we're going to put stuff into O, we're going to modify it. So it has to be, again, a non-const reference, because we don't want a copy of the class, and we want to be able to change it. So non-const and reference, so that it can be modified. If these explanations are difficult to remember, you can just memorize the pattern. This is what an iStream looks like, what a stream insertion operator looks like. This is what a stream extraction operator looks like. They're not going to change. The only thing that will change is the name of the class. But it's better to understand why they are the way they are, so you can reason it out just by quickly writing a little comment to yourself using a stream, and then, oh yes, that's how it should look. And then lastly, and I think this is where we'll stop before I start doing an example. No, let's carry on, and we'll do an example. Yeah, we'll do an example once we've covered the basics. Is the assignment operator. And the assignment operator is so important. It's part of what we call the big three. So for now, we've only had the big two in a sense, because if we have a destructor, it means we have dynamic resources that need to be released. It means we must have a copy constructor. But it's actually a little more than that. If we have either a destructor or a copy constructor or an assignment operator, any one of those, we have to have all three in our class for it to behave logically correctly, because the job of the copy constructor and the assignment operator are to perform deep copies of existing objects, where you actually duplicate the array or whatever it is and copy all the values from that to that. So that's the basic idea. Whether or not you return a const or not, or exactly what the return value is, that can be a bit flexible. I tend not to return const references, and I'll explain why. But let's think to ourselves, why does the parameter list look the way that it does? So let's say we've got a class called class, and we want to assign things to each other. We've got instances of the class A, B, and C. So if we look at regular integers, you are actually allowed to do something like this: A, B, and C. And assignment operators can be chained the same way that the stream operators could be chained. So this, for example, would assign 0 to all of these. And the way this gets evaluated is similar to the stream operators, except that the assignment operator is right associative. So it starts at the right-hand side, and then it must evaluate this. So what should the return type be? If we were naive and thought that all assignments must look like this, we might say, well, let's make the return type void, in which case we will get C is equal to void as our answer, which is, of course, wrong. So how do we make this work correctly? That's 0. Let's say we're doing it with our objects. Let's say we had O1, the class O1, O2, O3, and we had a pre-existing class called P, and we wanted to make them all the same. So O1 is equal to O2 is equal to O3 is equal to P, and we want them all to be equal to P at the end of the day. So we must evaluate from right to left. So what should be returned at the end of this? Well, you've got two choices, and both are acceptable. One is you return right-hand side, P, or you return the thing that got modified. The default is to return the thing that got modified and keep chaining. So basically you return, you evaluate that and you return O3, O3. You evaluate this and you return O3, O3, and you evaluate that and you return O3, and then that gets thrown away. But the end result is that each of these O1, O2, and O3 got assigned one after each other. And this is why the implementation looks the way that it does. It's a little strange, but it's it is the way that it is. So for a reason, and that's the reason for it, to support assignment chaining. So let's go through it and see if we can puzzle it out. Obviously, it's a member function. It has to be. The assignment operator is one of those operators that must be a member function, which means we only specify the right-hand side, right? Then there's a couple of things we need to do. There's a big difference between well, let's discuss what the difference is between doing this, O1 is equal to P, and something like this, class O4 and P, right? This is using the copy constructor to make O4 a duplicate of P, and this over here is using the assignment operator to make O1 a duplicate of P. How are these two things different, right? Why, what implications are different between an assignment that isn't there for a copy construction? And the answer is, in the case of the copy constructor, does O4 exist before this point in time? And the answer is no. O4 is popping into existence at this point in time and being sent the value P. There's no pre-existing memory or resources of any kind that need to be disposed of first before we can allocate and transfer from P. Whereas over here, O1 potentially has all sorts of stuff that's happened to it in its long history before it reaches this line of code. So all sorts of interesting things could have happened to O1 before it got assigned. So it could and should already have an existing internal state, including perhaps a dynamic array. So the first thing we need to do here when we do an assignment is delete everything that's inside O1, recreate it to be the same size as P's, and then transfer everything across. Whereas over here, there's nothing to delete first. So all we need to do is to allocate the space and transfer from P. So the responsibilities of an assignment operator are slightly higher than for a copy constructor. So that's what is going on over here. First things first is we need to delete everything. Let's actually go further. There's a longer description here. So this is all well and good. What happens if I do this? O1 is equal to O1. If my first step is to delete everything that's in me, then try and copy everything from the right-hand side, I will first be deleting everything and then trying to copy the stuff I just deleted. This is an error. Now, is self-assignment allowed? And the answer is absolutely yes. There's nothing wrong in C++ for doing this particular expression, C is equal to C. Is it common? No. Is it a good idea? Mostly, I can't think of it as being anything other than just weird, but it is allowed, right? And it could happen by accident if you have a very complicated set of logic and things moving around through different parameters, and you wind up assigning yourself something to itself at some point in your code unintentionally. Maybe there's big collections of these things that might include yourself already, and then you've assigned to yourself, and that's a problem. So we need to be able to accommodate self-assignment. So first things first is we need to check, are we already the right-hand side? If we are already the right-hand side, do nothing, right? You're done, you're finished, there's no work to be done. And if you're not the right-hand side, then you can safely delete your own stuff, allocate, transfer. So that's what's happening over here. Is we are testing, are we the right-hand side? How can we check if we're the right-hand side? Well, we've got a pointer to the current instance of the object at all times called this. So if we are the same as the right-hand side, our memory addresses are going to be identical. So that's what we're doing here. We're comparing this, which is a pointer to our object in memory, with the address of the right-hand side. If they occupy exactly the same space in memory, they are the same thing, in the same way as you cannot occupy the exact physical space as someone else without making them explode, for example. So we can safely say that if they're in the same place in memory, they're the same thing. So we test and see, is self-assignment occurring? If self-assignment is occurring, skip all the hard work. There's no work to be done. And just return yourself. Remember, we need to return ourselves to make the assignment chaining work. Now, this is the reverse of what's going on over here. Here we have a pointer, which we need to compare to a value. So we convert the value into a memory address with the address of operator. Now we are returning a value, but we have a pointer. So we take the pointer and we dereference it into a value and then return that, which gets converted into a reference rather than a pointer. So it seems really complicated, but again, it's the same pattern. All assignment operators will follow the structure. You just need to fill in the details for what do I need to delete and what do I need to copy inside it. So that's the basic structure of an assignment operator. As we said, there are some unary operators that exist. The thing with the unary operator, if it's a member function, you are already taken to be the object that's involved, so it will have no parameters. So if we were to specify the pre and post increment operator, plus plus, you don't need to specify in the basic case any other parameter. However, we'll see plus plus is actually slightly, and minus minus are slightly different, because you do need to differentiate between these two cases. We've got object plus plus or plus plus the object. Your logic will be slightly different. So there is a parameter in one of these two cases just to distinguish between the pre and post version of that function. So again, there's a reasonable chance you'll get one of those two or one of those four plus plus either before or after, minus minus before or after, because it's interesting and requires a little bit of special handling. However, if you've implemented the unary operator as a friend function, it'll have one parameter. There's no unary operators that I can think of that you have to implement as a friend function, so we'll pretty much always implement them as member functions. So here's the example with plus plus, and as I said, there's really four of them, of these things. There's plus plus before, plus plus after, minus minus before, and minus minus after. The default is the pre-increment version, right? So plus plus the thing. It doesn't have any parameters. As we said, its job is to modify and then return the modified state. That's what we're returning at the end. So think about that. Plus plus actually does have a return value. Let's say we were dealing with integers, and then I had int b is equal to plus plus a. The value of a is going to be equal to 2, and the value of b is also going to be equal to 2, because basically where the plus plus is, that's where the change happens. So a gets changed and the return value gets stored in b. They're both 2. If we did it this way, then the change happens there. So we get the old value of a in b, but a still gets changed. So there are differences between plus plus the thing and the thing plus plus. So our job is to deal with those changes. So we will need to return something at the end. And in the case of the pre-increment version, we must return the modified version. So take the change and return the changed version so that they're all the same. Whereas if it's a post-increment version, we need to specify a parameter, right? And oh no, sorry, this is the friend function version. We're not going to do it with the friend function, so I wouldn't really worry about that. But for the post-increment version, we need to specify a parameter just to distinguish between the two cases. This parameter is never, ever, ever used. It has no purpose in life other than to overload this operator between the two different cases. So you can just do it as an anonymous int. You don't even need to give it a variable name. You'll never use that variable inside your code. So this just tells C++ this is the post-increment version, thing plus plus. But what you need to do with this is you need to first back up your old value one way or another. You can use the copy constructor or the assignment operator. They'll both work. Do your modification and then return the old version. So if it was a plus plus, we back up the old version, which is 1, change a, and then return the old version, which gets stored in b. So those are the semantics of what we're going to be dealing with. I think this is a good place to stop. I'm going to check if there are any questions, and then we'll go through a worked example of this stuff in the extra tutorial, the pre-recorded tutorial that will be released this week, as well as in class. Mr. Satungu will also do some worked examples. So let's take a look for any questions. Okay. All right. Since we started studying, I've already seen our pointers help us create dynamic arrays. Please correct me if I'm wrong. When we create vectors, okay, now understand a vector is just a dynamic array inside a class. So what happens with a vector is it's actually using the dynamic arrays in its private state to do the work for you. So it's a great example of abstraction. It's hidden or information hiding. It's hidden the complexity from you. You don't need to know about the resizing and about the allocation and deleting of those arrays, because it happens automatically. It's hidden from you. It's a nice abstract data type. Whereas you are now trying to create your own data type. So you need to handle all of that work internally. You must think of yourself as the creator of data types other people will use, not just as a programmer who's going to use pre-existing data types. So, but then it's just going over here. Every time we need to resize the array, we create a new one. Yeah, so that is how resize works. There's no resize operation in C++ like there's redim in Visual Basic. You'd have to create a new array that's the size you want, copy everything from the old array to the new array, and then delete the old array. And vectors handle all of that automatically for you. What is the difference with printf and CF? Printf is the C function that does basically a very similar job. It's the formatted print statement. We will tend to use cout. It's the more object-oriented one. Yeah. Yeah, printf is faster, and some people like the formatting strings that you can use with it, but we will stick to cout. But a good question. Yeah, you can use C functionality in C++ without any hassle. So that's the reason why you can see it. Some people do, particularly people who started programming in C, will still use printf without really thinking about cout. Cout is a little slower, though. That's definitely true. If you're worried about speed, then printf, go for printf. But remember, the cout is a fully fledged object and supports I/O manipulators, which printf doesn't support. So, like with many things, it's a decision: is the raw speed for output necessary, or is the flexibility of things like I/O manipulators useful enough to pay for that cost? Are virtual functions allowed inside friend functions? They don't have any meaning as far as I can think of, because virtual functions are related to being a class. And the friend functions are non-member functions. So I've never seen it done, but I'm not comfortable saying it's impossible until I look into it. So it's a great question that I don't have the answer to, but it doesn't make much sense to me off the top of my head. So I'm going to cautiously lean towards no, but obviously C++ is a very big language, and it's quite possible that there could be something I'm overlooking now. Because so yes, I think so. That sounds reasonable. Right, can we have a virtual function without a pure virtual function? Yes, you can. You can create a default implementation for a virtual function if it makes sense. It'll still be polymorphic and work correctly, but you'll have a default in the base class. You absolutely can. The revision takes place in these tutorials, and there's already been 2 tutorials which are available from Eve. Each tutorial is different, covering different past papers, and we sent out an email to everyone explaining this. So please make sure to check your emails, as well as make sure to watch the other tutorials which are available through Eve. Okay, and someone has answered that. So I think we're done. Thank you, ladies and gentlemen, and see you later.